talk about how we get some weird numbers in logs. Before we get there, we're going to talk about exponent rules. So we'll put exponent rules, and you're going to see why I'm doing this. Exponent rules. Okay. Some of these, all of these you should know. So I'm going to give you just the basic, well, I'm throwing markers. I'm going to give you the basic, and then I'm going to give you examples. So if I give you, for instance, let's do this. B to the n times b to the m, okay, equals, wait, sorry. When you add, you multiply. Sorry, when you multiply, you add. So in other words, if you have b, they have the same base. So how these both have b's. Then you add the exponents, b to the n plus m. Okay, here's your example. We're going to use 2 to the third times 2 to the fourth equals what? 2. What do I do with my exponents? I add them 2 to the 7th. All right. So that's what happens when you multiply. Let's see what happens when you divide. B to the n over b to the m equals b to the n minus m. All right. So if I have 2 to the third, watch, I'm going to do the same numbers, over 2 to the fourth, I get 2 to the what? It's going to freak you out. To the negative 1. That's okay. It's okay to have negative. But we're going to talk about what this means. So you're going to have one more step here. Let me give you a normal one before I give you that one. Okay, so let's leave that because we're going to still use it. But if I give you 2 to the fourth over 2 to the third equals 2 to the positive 1. Okay, let's do that. All right, now let's do a negative. So b to the negative m, okay, equals 1 over b to the m. So it makes it go to the negative. So if I have 2 to the negative 1 like I had before, this is really 1 over 2 to the first. Okay? Now, hopefully you got that. I'm erasing that. I'm going to add some more. So keep going. Keep adding down. The next one is if you have a fraction. Now this one's hard. Okay? No, I'm sorry. If you have a radical or a fraction. We'll go both ways. So if you have the n root of b to the m. Okay? So it's like the third root of b to the m. Then you're going to get b to the n over m over n. Okay? So if you've got the square root of 2 to the third power, okay? This is really 2 to the 3 over what? What is here in a radical? If it's a square root, you're finding the second root of something. So if there's nothing there, that's a 2. Okay? So this is a 3 over 2. I'm going to erase that. But you need to remember there's a 2 there. There's nothing there. Alright? Now let's do it the other way. So if I have b to the 1/2, okay, then I get, oh, sorry, not half. I'm crazy. M over n, I can go both ways. I get the n root of b to the m power. So if I have 2 to the 3 over 2, I get the square root of b cubed. 2 cubed. Wow, my brain's not working this morning. 2 cubed. Okay, make sense? Hope so. That's your exponent rules. That's all of them. Now, we're going to do log rules. They're very, very similar. So log rules. Oh, I forgot an exponent rule. You can hate me if you want to. I'm adding one more rule because I forgot it. If you have b to the m raised to the n power, it's b to the m times n. So if it's 2 to the third raised to the second power, what do I do with that 3 and that 2? I multiply 2 to the 6th power. Okay, that's the last one. Now I promise I'll leave you alone. Alright. Now log rules. I don't know why I just erased all that. Log rules. If I have log base b of n plus log base b times n of m I need more. Log base b of m, then I get what? Log of base b m n. So it's just like the other one. When you add, you multiply. Okay. When you multiply, you add. Either way, you multiply. So if I have log base 2 of 3 plus log base 2 of 4, I get the log base 2 of 12. Okay, those are the same thing. Can you see that 12 over there? Yes, you can. Okay, how many minutes am I at? Oh, I gotta hurry. Okay, so now that's my first log rule. Your second log rule is if you have the minus, let's see, we're subtracting. Log base b of n minus log base b of m, then it is equal to log base b of n minus n over m. The first one over the second one. Okay? So, if I have log base, let's keep going with the 2 and the 3. 2, 3 minus log base 2 of 4 equals log base 2 of 3/4. Alright? Okay, let's do the last one. That is, if it is, now this one's weird. If you got an n times log base b of m, okay, so I have that. That's equal to the outside becomes exponent. Sorry, log base b of m to the n power. That one's weird. Okay, it's the only one that's weird. So this guy goes inside and becomes a power. So if I have log of, let's keep going 2, 3, 2 log of 3 times 4. Okay. 2 times log of base 3 of 4. So they're stuck together, so it's still multiplication, but when you multiply it becomes an exponent. So it becomes log base 3 of 4 squared, which is log of 16 base 3. Okay, so the one on the outside becomes the exponent. Outside becomes the exponent. So it became 4 to the second power, 4 to the second power. That's your log rules. Okay, I've got one more log rule for you, but I don't think I can squeeze it down here, so I'm going to erase this. Okay, I know this is a lot I'm throwing at you, but I promise you'll be good. Alright. Remember, you can use your notes on all your worksheets and even on your quiz. Okay, last log rule. This one is weird. Okay, if you have n to the log base n, I think it's log base n. Give me 2 seconds. N to the log base n, yes, of m. Okay, log base n. So now all this log becomes an exponent. So it's n to this power, the whole thing power. Then all you're left with is m. So if you've got 2 raised to the log base 2 of 84, say I have that. When you raise a log as a power, it cancels the whole thing out as long as it's the same number here. Then this answer is just going to be what? 84. Okay? Good. Now, that's log. So log naturally has a base of what? 10. Now I'm going to show you another number. This number is not really a number. It's like pi. So remember how pi goes on forever? 3.14157, I think 9. I don't know. It goes on forever. So pi goes on forever. I'm going to give you another one of those numbers. It's a rational number. That's what those numbers are. Irrational. And it's E. So E is like 2.1828. I just remember that because it's like our area code. And then it goes on forever. So this number goes on forever. What is this number? Well, this number is found in nature. That's what everyone always says. It's really just a weird number that came up out of nowhere. So you know, to get pi, you do the circumference divided by the diameter. Well, this number comes up in calculus. It comes up in statistics. It comes up in all these random places in math from all over the place. And it was discovered by a man named Euler. Euler, I think it's how you say his name. Discovered E. E. Well, it wasn't really E, it was a number, but they named it after him. So that's where the E comes from, is his name. Okay, it's Euler's number. Now, it's discovered, he's not alive anymore. Discovered E, okay? So let's talk about how this plays into logs. They use this number in logarithms all the time, all right? So if you have a log base E, okay? So if that number is as your base of a number, let's put n, okay? Instead of writing this log base E thing, they replace that with this, ln of n, okay? So let's change this to m so it's not confusing, okay? They replace log base E of ln. So if you see log or ln, I want you to think log base E. So if I give you this, if I give you e to the ln of 10, what's the answer going to be? Okay. Think about the rule I just gave you. E to the log base E of 10 would be 10, right? Well, what does this ln mean? It means log base E. So this answer is just 10. You're going to have problems like that, so make sure you understand them. This ln, this is the log of the natural number. Log base natural. That's what it stands for. Okay? Because E is the natural number. I don't know why. That's what it's called. I think that's all you need to know. Oh, I'm going to show you the graphs. The graphs kind of make sense once you see all of this stuff I'm giving you. So as you can see, logarithms and exponentials are very related. But I'm going to show you the graph so that you can see how they're related. So let's do the exponential first. Exponential. Okay? Exponential and logarithm. And exponential, you've seen this curve 1,000 times in your life. So let's say here's my x and my y. Okay, it looks like this. It starts low, and guess what it does? It gets super fast, super quick. Okay? If there's ever a zombie apocalypse, this is what will happen. A few people get bit, and then all of a sudden, boom, everybody's a zombie. Okay. Logarithm kind of looks just like that, except it's been knocked over. Okay? It's like someone took and punched that logarithm, punched the exponential really hard in the face, because it ends up looking like this. So it's like starts here. So just like how this one kind of starts here, it goes up, 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 and then all of a sudden whammy, okay, exponential. So see how it kind of like fell over? It's like the exact same graph, but it kind of fell over. So that's what a logarithm looks like. Now exponential can go the other way. You can start here and you can decay really fast, or you can go off and fall off the mountain, okay? But it's all about getting fast, quick, or decreasing quickly. Getting fast, quick, or decreasing quickly. Those are your two graphs. You need to know what they look like, because I'm going to show you both of them and ask you which one's which. Okay, that's all I got. Thank you and good night.